Welcome everyone to this Lightboard session where we're going to learn a little bit more about vSAN. In this session, we're going to look at how the new Express Storage architecture in vSAN 8 is able to deliver RAID-1 performance using RAID 6 erasure coding or any kind of erasure coding that we have available in vSAN.
So oftentimes in storage, every decision you make has a trade-off. You're trading capacity for performance. You're trading a CPU overhead for networking bandwidth. There often are compromises you have to make. And historically, with the original storage architecture, when you try to decide what RAID level to use, we would talk about, okay, RAID 1 will perform better on writes. If you have a read-heavy workload or you're more concerned about capacity costs, then maybe the RAID 5 or RAID 6 would make sense. But there was a kind of a decision matrix, and depending on the application and use case, we might have to have a little bit of a discussion. What we've tried to do with the Express Storage architecture is give you the performance of the RAID 1 type design from a write optimization with the capacity benefits of a RAID 5 and RAID 6 type design. And we think we've achieved that. Now we're using a new vSAN log structure file system, and this log structure file system goes and it coalesces multiple writes together within this performance leg that follows a RAID 1 type structure, does a mirroring type protection, and it's going to compact that data, it's going to compress that data potentially, it's going to pack in the metadata, because actually as you scale really large storage systems, the metadata actually becomes quite a chore. And it's going to grab that data together, and as that data goes cold, as it ages out, it's going to then move to the capacity leg. Now, the initial write acknowledgement is going to happen in our performance leg, but as it moves to that capacity leg, we're going to do what's called a full stripe update. We're going to not have to look at the data and then do that read, write, modify, calculate parity. We're able to write the data as a full stripe so we can not have that overhead.
Yeah, John, I think this is a great example of how we were able to take advantage of some of the existing elements in vSAN, some of the existing data structure, and adjust it to where we could write the data quickly, but also package it up in a really efficient way so that when we write something efficiently, that being like a RAID 5 or RAID 6 stripe with parity, that we're doing it all at once and with as minimal I/O and CPU amplification as possible. And this is such a great representation of that, because when we're really looking at these two new legs of an object, which this is where we can see how we are able to take advantage of this new architecture using the new log structured file system within vSAN to deliver that performance and space efficiency without any compromise. And that's really one of the key benefits here about the ESA.
And one thing I'll note is you may look at the performance leg and say, well, is that not a lot of capacity overhead? Because it is a different that. We're in the megabytes here per object. So this is actually, very low in terms of the amount of capacity it's going to live within this side. We're going to get these performance benefits, but we're not generating a lot of unnecessary overhead, and your math for figuring out usable space is not going to get that complicated.
Yeah, for the most part, when you're doing the the design and sizing exercises through our vSAN sizer, you're just essentially going to have the same overheads that you would normally have. But because we're able to take advantage of addressing performance and capacity in the same manner, that means that all of your storage devices within a vSAN ESA architecture are contributing to both performance and capacity, and that helps you drive down the TCO, improve the manageability of it because you're not dealing with discrete storage devices and with different purposes. This makes it easier. From a management perspective, we're just telling you what it looks like from behind the scenes. Operating vSAN is really no different. You're not going to see these components. They're not a manageable entity, just the object. You're going to describe or prescribe the outcome based off of the storage policy that you want, and then vSAN's going to do the rest. If you'd like to learn more about the Express Storage architecture and some of the benefits of it, feel free to go out to core.vmware.com to learn about that and all things related to vSAN. Thank you very much.